guys, so today we're going to talk about logarithms. So first we're just going to talk about the general concept of what a logarithm is, and then we're really going to get into some examples which hopefully help it make more sense. Okay, the logarithm of a number, we'll call it x, is actually the exponent that a certain number that we refer to as the base must be raised to in order to give us x, to give us our x. So let's look at what that means. If I have something that says log 25, okay? When you see something like this, this is the base that we're talking about, and this is the x in that definition, okay? And what this is actually asking you to do is this. It's saying, what do I have to raise this base to? What power do I have to raise this base to give me 25? So when I set it up like this, we can see that our answer is going to be 2, because 5 squared is going to give me 25. So let's look at what a common logarithm is. So common logarithm is well, first let me say that it's you know that button on your calculator when you hit log, that's the common logarithm, because it's a log with base 10. Now in that last example you saw that the base was 5, so here our common logarithm always has our base of 10 here, okay? So a lot of times you'll see things like if I just say log 100. Now if you remember, I'm just going to rewrite that, the last example that we did, I'm just going to rewrite it up here. Like the example I said was log 525, okay? So here our base was 5. Now here you notice the base isn't written in, and when it's not written there, we can assume base is 10. Okay? We automatically assume that if another number isn't written in there, that it is base 10. And when you do hit the log button on your calculators, you know, I maybe up until this point, I know sometimes those graphing calculators, they're a little overwhelming. You know, you're not quite sure what happens when you press those buttons. Is there a rocket being launched somewhere or something? But actually, no. When you hit the log button on your calculator, okay, when you actually, if you type in log 100 on your calculator, it's going to give you 2 as an answer. And what this actually means is, now remember this is the base 10 here, so what you're actually asking your calculator to figure out is this: 10 to what power is going to give me 100? Well, 10 to the second, right? Because 10 times 10 equals 100. So that's actually what's happening when you're hitting that log button on your calculators, and that's our common logarithm. So some of you, I'm not sure if all of you have talked about natural logarithms, but I am just going to mention it just in case. So natural logarithm, pardon the messy writing as usual here, is a log with base e. So if you're seeing this e and, oh, what is that? I haven't seen it before. Well, you probably don't need to know it. You probably haven't gone over it. And e actually does have a value. E actually equals 2.178, blah, blah, blah. So basically, it's the same concept, except, let me say this, it's represented, our natural logarithm is represented as ln. So this is also a button on your calculator. So when you hit that button on your calculator, if you hit the natural log button and you say ln 100, what you're actually asking it to calculate is this. You're saying, okay, e to what power is going to give me 100? Okay? That's what you're actually asking it to do. So, okay, so hopefully you're starting to get the concept a little bit of this logarithm thing. So now we're really going to start to delve into some examples that will hopefully make it even clearer for you. All right? Okay, so let's do some examples with logarithms. First, I just want to draw your attention over here to the logarithm rules that I just jotted down. Definitely copy these down, commit them to memory, and what I suggest you do as a strategy would be to, when you go to take a test on this, just jot them down in the corner of your paper, just so that you have them to refer to, so that you don't feel the pressure of keeping all of it straight in your head. Okay. So as we go through some examples, you'll be able to see how these rules apply. So first type of problem you might be asked is to write the logarithm in exponential form. Okay. So what you're going to do there is this. All right. When we look at this, know that this is actually going to become our base. 4. It's a little too messy even for me. So this is our base in our exponential form. Okay. This is the guy over here. All right. And remember, logarithm is actually an exponent, right? So this guy is going to go right here and then equals 16. Now these types of problems you can actually check to see if they're correct, right? Because you can say, okay, does 4 squared equal 16? Yes, it does. So you're all set. You're good to go. So let's look at this one. Here, our base is going to be 50. Okay? And our exponent is going to be 0 equals 1. Does 50 to the 0 power equal 1? Yes, it does. And if you didn't know that, you got to go back and unfortunately maybe review some of those exponent rules, okay? Because this one will come up a lot. Anything to the 0 power equals 1. So remember that one. Okay. Next, you might be asked to evaluate the logarithm, okay? Now you might look at it and say, you know what, I don't like it. That's my evaluation of it, but unfortunately you can't put that as an answer. So, okay, so let's again go back and think, okay, what is this asking me to figure out? What it's asking me to figure out is 12 to what power is going to give me 12, okay? And the answer is going to be 1, right? So our answer, I'll just erase this. So our answer is going to be 1 because 12 to the 1 gives me 12, okay? Next example, 7 to what power is going to give me 49? Well, 7 to the second gives me 49. So I can just fill in 2 right there. Okay? So that was a little bit like the example I had given you when you were talking about the definition. So hopefully these patterns of the logarithms, they're becoming a little bit clearer to you. So let's do a couple more examples. All right? So hang in for some more examples. Okay, so couple more examples with logarithms. All right, we're now just going to talk about simplifying the expression. Now, for these examples, we're really just going to want to pay attention to these last 2 rules here. And like I said before, really it's in your best interest if you just memorize these guys, and when you're going to take a test, just jot them down the corner of the paper somewhere just so that you have them to refer to, because it'll make it a lot easier. So let's look at this first example for simplifying the expression. 7 log 7x. So this one, pretty straightforward. We can see that it matches our pattern here, our rule here. So our answer is just going to be x. For our second example, we see, the log 5x. We see that it matches up here. This can be x. Now, for this third example, I included this because it's one of those tricky ones. It's one of those they'll throw in and, where is this coming from kind of thing. All right. For this one, you have to remember what I explained to you earlier when we were talking about definition of logarithm, and then I went on to explain what a common logarithm is. Now, if you remember, we talked about common logarithm having base 10. And when we write a common logarithm, we don't write the base of 10 there. We assume that it's there. So this is actually a base 10, okay? But they were sneaky, you know. So just know that we then now have a similar situation to these other examples. So our answer is just going to be 8 there. So just be aware of things like this. If they don't immediately match these patterns, just take a second and think, okay, you know, is there a way I can get it to match up with the rule? That's, I think, the best way to approach these types of problems, simplify the expression. So if it doesn't, you know, match up to one of the rules over here, how can I, you know, ask yourself, how can I get it to match up? And in this case, you know, you just got to remember that common logs will just be written straightforward, log and the number, and they don't put that little, you know, base 10 in there, you know. So you have to remember that that's the story there. Okay, hope this was helpful. Hopefully logarithms don't seem as convoluted and crazy as they were before you started. So, all right, good luck.